Hello and welcome to a MathCat session where we're going to talk about some grade 10 math. We're using IXL to look at a variety of examples and make it a little bit more convenient. Feel free to check them out or use any other platform where you can practice these things and get feedback. We're going to look at some rational exponents today. Just an introduction, so nothing too fancy, but a lot of algebra and things that are coming up in grade 10, 11, 12 rely on these concepts. So just remember that if I have the cube root of a number, or it could be any root really, we write that as a fraction exponent or a rational exponent. So the square root of whatever number will be that number to the 1/2. So it's another way to link the roots to exponent properties. And if you think back, we had a times b in a root a times root b where possible. We can write this as a times b all to the 1/2, and then we have the same exponent property again. So roots are really not anything new. I tell my students that when I'm doing algebra or more complicated things, the rational exponents are handy. And when I'm trying to do a calculation and get a sense for a number, sometimes the roots are handy. So it's very important that we're able to flip back and forth between these. So when I have a very simple example, 1 to the power of 1/3, I can look at it in this version, but always feel free to switch to the corresponding root version if that fits better with your number sense. Sometimes because of properties that I'm using for convenience, one is better than the other, but I should always be flexible and go to the one that's more convenient. So in this case, I have a number there. So my number sense is a little bit better when it comes to roots. Cube root of 1. Well, if I say, let's make it super simple. I'm trying to figure out the cube root of 1. I know it's a 1, but it's not always going to be, is something. That equation I can rewrite as 1 equals the something to the power of 3. And I have to get a 1, so the question mark has to be 1. There's a lot of different ways you can do this. I'll try and mix it up a little bit. You can also look at the exponential side and say, well, 1 to the power of anything is 1. So there we go, 1. So there is definitely scaling in terms of complexity, as well as my goal, what I'm trying to do. For this introduction, we're just trying to simplify some things so it's not always the most complicated, but I want to get a nice platform at the same time that I can build on. So if I look at 81 to the 1/4, perhaps I'm not quite sure. Ooh, well, do I switch that to the 4th root? Well, that doesn't help me unless I know 81 perfectly, and that's not always going to be the case. So again, multiple ways to do it. You might know 81 and can exploit the 81. For example, it's 3 to the power of 4, but maybe I didn't know that. So the 4th root cancels the power of 4 and I get a 3. But what if I didn't know that? What if it's a weird number? Well, I can go this side and use exponential properties in a more conventional way, perhaps, or a more reliable way by splitting up this 81. Now I can go factor tree and get the prime factorizations and break up this 81. Maybe you recognize it's 9 times 9. 9 is 3 times 3, 3 times 3 for that 9. These are all prime numbers, so that's as far as my factor tree can go. And of course, if I talk about a factor tree, we're building on top of previous concepts. If I talk about anything and you're like, whoa, I don't know what that is, that just means you need to go back and your foundation isn't quite ready for this topic. So for example, let me go here, scroll down a little bit. Square roots and perfect squares, cube roots, powers with integer bases, I would say factoring, all those things we build on for this, potentially. So I will write 81 as 3 to the power of 4. That's all inside. Now remember, my exponent property says that I can multiply these, so I have 3 to the power of 4 times 1 over 4, which is 3 to the power of 1, which is 3, same as what we found there. So what makes this a little bit intimidating, perhaps in the beginning, is I do have multiple ways of simplifying a rational exponent expression. They are equivalent, and it's just different ways of saying the same thing in the language. You think about uh, speaking English, you sometimes have different ways of saying the same thing. And depending on the situation or your needs or your audience, you might want to say it in one way and not the other, but they have the same meaning, and they are options depending on your goals. This is a simpler one. I have 4 to the power of 1 half. Since we're not talking about roots as much right now, let's try and stick to the rational exponents. So I simplify 4 and then use an exponent property, 2 to the 2 times a half, and that's 2 to the 1, which is 2. So all good. I'm just trying to become aware of roots, rational exponents, and the same exponent properties. Let's do this one. Oopsie, that was supposed to be a 7. Let's get rid of that. 27 to the 1/3. Maybe I have to go and say, what's 27? 3 times 9. That 3 is done. 9 is 3 times 3. So 27 is going to be 3 to the power of 3. Now for this introduction, everything kind of works out nicely. That's not always going to be the case. Maybe I want to put a little time symbol there. Maybe that makes me happy. I get 3 to the 1, which is 3. Again, same factor tree I'm building on, exponent properties I'm building on, familiar things, allowing me to simplify these things that are slowly looking a little worse and worse and worse as I progress. I look at 243 to the power of 1/5. I can honestly tell you, I don't know what the answer is. I don't need to know. All I need to know is how to approach this. People look at this as like, oh, if I don't know the answer right away, well, I must be dumb, or my brain doesn't work like this. Math is just not my thing. I can honestly tell you right now, I do not know what this answer is, and that is okay. All we need to know is how to read this, how to approach this, and systematically how to get to the answer. I don't need to know the answer. It's okay. So 243. Well, this number is bigger, less convenient. Looking for some factors here. What is a factor of 243? Maybe I need to play with my calculator a little bit, right? Let's demonstrate varying degrees of skill here. Maybe my arithmetic's not that great. Maybe I need to play with my calculator a little bit. 243, 243. Or maybe I remember some divisibility rules, but I'm not quite sure. I see the sum of the digits is 9. Does that mean it's divisible by 9? I'm not sure. I'm going to divide it by 9 and just check, right? Oh, it's 27. Okay, good, good, good. Maybe I can make some progress that way, right? There are options, and don't feel that restricted. Did we say 9 times 27? I wasn't actually reading. We can double check. Oh yes, 9 times 27. Okay, good, good, good. 9, I'm trying to write here. 9 times 27. Okay, now these are smaller. Okay, now I'm back. Feel more comfortable. That's okay. 27 is 9 times 3. I got a lot of 3's here. Now don't think this is just in the beginning that they're giving you, in this case, 3 to the power of 5. We're trying to build this slowly with our introduction. It's not always going to be a perfect 1 when I multiply these guys, right? One thing at a time. We're getting used to the method in a slightly comfortable environment. And when these numbers get more complicated and they have multiple different prime factors, different exponents, well, we'll build up to that. Right now, this is just our introduction, and we got a 3. Excellent. So you can try this one and let me know in the comments, what do you think is the answer to this one? If you need more practice, go to IXL for more practice. There are many other websites as well. Whatever works for you. Let me know in the comments what you think this answer is. And if you have any questions, don't hesitate to let me know. Until next time then.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.